Hello everyone, and welcome to my channel. This channel is for educational purposes and um, try to inform our listeners about different subjects that we feel are important, mainly theories of everything and all-encompassing theories, magnum opuses from obscure authors, and other things that you might not have ever come in contact with, but if you did, they would enrich your life by giving you a holistic worldview or holistic alternative, um, and present you with different options in your life that you could exercise. Today is our 382nd video on the reciprocal system of theory from one Dewey Bernard Larson. And Mr. Larson lived from 1898 until 1990 and left behind a lot of books and articles and talks that he gave. We're going to be going through one of his articles a little bit later here. Mr. Larson put out his two fundamental postulates in 1959, which were basically an outline of the theory, and then he developed a theoretical universe based on those postulates. And so through a process of deduction, just logical reasoning, if this then that, he took his postulates and turned it into a theoretical universe. So if my postulates are correct, this is what the universe would look like. And then in his books, he compared his theoretical universe with the empirical universe that the scientist had observed, measured, and compiled, documented and compiled over the years, and particularly in their scientific tables. And Larson would come up with these same type of values strictly from theory and then compare the two. And it's pretty phenomenal that sometimes, in most cases, Larson would be within 0.1% of the same value in a lot of the cases, the vast majority. And then when there were discrepancies, Larson was usually able to explain why the legacy scientists' measurements were wrong. So now the reciprocal system is difficult to grasp, and Larson did a great job of putting everything together, but he's only one person, and so he was, kind of in over his head in terms of trying to document everything. He just had too much on his plate. Now, there have been a few other people who've come along over the years and have tried to refine the theory and modernize this theory, especially since Larson died. But, the theory in general is it could fall by the wayside and just fall onto the scrap heap of history, where not enough people know about it, and it's not able to maintain through the generations for us to figure out that he finally figure out that he is right. So that's kind of why I'm putting out a lot of videos on this, not because I'm an expert on the topic, because I'm not, and but it's because I'm hoping that some people come up after me and watch these videos, and maybe it clicks with them, and they put the word out as well. And so eventually we can develop some kind of systematic study of this. And I would like to try to put out a textbook on this, because I think that Larson was a good writer, but he wasn't really that good of a teacher. And so the information is in there in his books and so on, but you have to draw it out. It's not um, it's not it's for a digger and not so much just for a lay audience. And he goes into every subject that he could get his hands on. He's got books on physics and chemistry and astrophysics and astronomy, but he also has books on economics, and he's got many chapters um, devoted to metaphysical subjects, including psychology, philosophy, religion, psychic phenomena, ethics. And they all come from the same theory. So he's just got one theory and he plugs it into every subject. Wouldn't that be, a good foundation for a school curriculum, or a, generalized universal curriculum, if it was found that the results were commensurate with reality? So I think it's worth looking at. And the basic idea behind the reciprocal system is that we live in a universe made out of motion. His first postulate says that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. The second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Now, Larson's second postulate is far more disputed than the first. The first is where, that is the primary postulate as far as I'm concerned. And, basically, the universe is made out of motion, specifically a type of motion that he called scalar motion. That is a motion that has a magnitude but has no specific direction, which you can visualize using a balloon with spots on it. If you blow up the balloon, all the spots move away from each other, but in no specific direction. And motion is the relationship between space and time. Space and time are therefore reciprocals of one another. And like all reciprocals, they share in identical qualities. So whatever quality adheres to one also adheres to the other. 3-dimensionality being one of those, and scalar motion or clock type motion being the other. They both only come in discrete units. You have to have a full unit before you have anything. And if you have 1 unit of space in 1 unit of time, then you have the speed of light, which is what Larson calls unit speed. 1/1 equals 1. And this is the background motion of the universe of motion. So in a universe of motion, you always have motion. It is omnipresent. And in particular, it is outward at the speed of light in all directions. At the speed of light, yes. And half the universe is moving faster than the speed of light, and half is moving slower. He refers to these as the cosmic sector and the material sector, respectively, and they are reciprocals of one another. And time and space don't have any real existence. They only exist together in motion. They can be abstracted, but you have to have both in reality. And then he goes from there. We are looking at a paper that he wrote back in the day. I don't know what the date on this is, but it's called How Much Do We Really Know? And this is a paper that Larson, that's mainly a history of science. And I thought Larson was informative historian of science. In his books, he usually, when he talks about a subject, he usually goes over the history of that subject from a history of science standpoint, like how did the science, the state of current science, get to where it was? What were the players doing, and why were they doing it? What are the trends involved? Why do people think in a certain way? And in this paper, he's spent some time going over just the fact that especially theoretical scientists, theoretical physicists, and astronomers, that they have an inflated view of how much they know. The rank and file scientists think that these problems have all been solved. They think that they actually have knowledge about certain subjects. But if you actually listen to the actual front rank scientists, the leaders in the field, they all know that they just have a hypothesis that is better than maybe what they had before, or that, and they're literally salivating for a general theory that they could employ across the board, instead of just using these piecemeal theories that they can only apply to one subject at a time. And but they still are not thirsty for Larson's theory, even though it is exactly the kind of generalized theory that they're looking for, because they recognize that if they took on Larson's theory, they would have to admit that they were wrong, and they would have to adapt to an unfamiliar system. And so all of their hard work in mastering the current state of science would be for naught. And so that's kind of where Larson is going with this. And then he looked at a few specific examples, the hydrogen to helium process in stellar burning, and showing that it has no type of standing in terms of reality, but the astronomers go there anyway because the physicists went there. And then there was a question of stability of certain elements, particularly I think it was iron 56, but also the neutron. The neutron is unstable, but nonetheless they make it part of the atom, and they say that for some reason the neutron is stable in the atom, but when it's not in the atom, it's not stable. They just kind of do these things and use various means of covering up in order to justify what they're doing. It sounds a lot like the political situation, as a matter of fact. It is basically political, and they use a lot of censorship and obfuscation and other deceitful means to maintain their power, more or less. Now, we went through this paper over the last 3 days, so if you want to go back to the start, You want to go back 3 days. So this will be the 4th installment, and we're starting, in the middle of the paper there. Okay, conclusions outside the scope of the observations are not knowledge. Somewhat analogous to the practice of extrapolation, but of a more questionable character, is the practice of exaggeration, that is, claiming more than what the observations or measurements actually substantiate. A classic example is Einstein's theory that mass is a function of velocity. Throughout scientific literature, this theory is described as having been, quote, proved by the result of experiment and by the successful use of the predictions of the theory in the design of the particle accelerators. Yet, at the same time that a host of scientific authorities are proclaiming this theory as firmly established and incontestable experimental fact, practically every elementary physics textbook admits that it is actually nothing more than an arbitrary selection from among several possible alternative explanations of the observed facts. The experiments simply show that if a particle is subjected to an unchanged electric or magnetic force, the resulting acceleration decreases at high velocities and approaches a limit of 0 at the velocity of light. The further conclusion that the decrease in acceleration is due to an increase in mass is a pure assumption that has no factual foundation whatsoever. As one textbook author explains the situation, quote, "There seems to be no reason to believe that there is any change in the charge, and we therefore conclude that the mass increases." Another says, quote, "This decrease is interpreted as an increase of mass with speed, charge being constant," end quote. Obviously, an interpretation of the observed facts is not a fact in itself, and it is rather strange that the theorists have been so eager to accept this particular interpretation that they have not even taken the time to examine the full range of possible alternative explanations or interpretations. As these quotations from the textbooks indicate, it has been taken for granted that either the charge or the mass must be variable, but actually it is the acceleration that has been measured, and the acceleration is a relation of force to mass, not of charge to mass. The accepted interpretations of the observed facts therefore contain the additional assumption that the effective force exerted by a charge is constant, irrespective of the velocity of the object to which it is applied. The possibility that this assumption is invalid cannot logically be excluded from consideration. On the contrary, there are some distinct advantages in maintaining both charge and mass as constant magnitudes. When we get down to bedrock, it is clear that the theory of an increase in mass is not something that has been proved by experiment, as is so widely claimed. It is a pure assumption that goes beyond the scope of the experiment and is only one of several possible alternatives. Any theory which leads to the observed decrease in acceleration at high velocities is equally as consistent with the observed facts as Einstein's theory that the mass increases. A principle of impedance is not knowledge. One of the disturbing features of current scientific practice is the increasing tendency to rationalize failure to solve difficult problems by setting up postulates that solutions to these problems are impossible. As Alfred Land puts it, quote, "In short, if you cannot clarify a problematic situation, declare it to be, quote, fundamental, then proclaim a corresponding quote, principle. Herbert Dingle quotes a physicist who even goes so far as to contend that we are at last firmly grounded on the principle of uncertainty. And these are no minor matters out of the periphery of physical theory. They are matters of vital importance to the foundations of theoretical structure. Quoting R.B. Braithwaite, quote, such propositions, principles of impedance, play a very large part at the present time in the fundamental theories of physics. It should hardly be necessary to point out that from their very nature, these principles of impedance are incapable of proof and are never entitled to the status of established facts. It is very doubtful whether they should even be recognized as legitimate scientific devices, to say nothing of being given any authoritative standing. Some of them should certainly be barred. The underlying concept upon which all scientific research is based, and without which the application of time and effort to this task would be wholly unjustified, is the conviction that this physical universe is essentially reasonable and operates according to fixed principles. Thus far, we have never encountered any actual evidence to the contrary. As scientific knowledge has expanded, one after another of the phenomena that were inexplicable to our early ancestors has been found to follow fixed and unchanging laws. But now there is a growing use of a practice which is not only questionable by nature in that it is an easy way of avoiding the difficult task of solving complex problems, but also leads to conclusions which are in direct opposition to the philosophical premise, which is our only justification for understanding scientific research in the first place. Conclusions such as this from Heisenberg, quote, the idea of an objective real world whose smallest parts exist objectively in the same sense as stones or trees exist, independently of whether or not we observe them, is impossible. Or this from Bridgman, quote, the world is not intrinsically reasonable or understandable. It acquires these properties in ever-increasing degree as we ascend from the realm of the very little to the realm of everyday things. Or this from Herbert Dingle, quote, the real world is not only unknown and unknowable, but inconceivable. That is to say, contradictory or absurd. These statements are all completely at odds with the underlying philosophy of scientific research. If we had some definite and positive evidence that they were true, we should have to accept them, however unpalatable they may be, and accepting them purely on the strength of principles of impedance, which means that they have no factual support at all, is totally illogical. The bald truth is that these statements are simply efforts to avoid admitting failure. The theorists have failed in their attempt to discover the exact physical and mathematical properties of the component parts of the atom. And rather than admit that their abilities are unequal to the task, as C.N. Yang suggested in the interview previously mentioned, they prefer to postulate that these properties do not exist, and that even the atom itself, as Heisenberg says, has no immediate and direct properties at all. The ironic part of it is that it is now beginning to become evident that the task at which the theorists have failed is not an impossible task, as they would like to have us believe. It is a meaningless task. As will be brought out later in this memorandum, a growing mass of evidence indicates that the atomic constituents whose properties have been so difficult to define simply do not exist at all. a possibility that should have been given serious consideration long ago. When the most strenuous efforts over a long period of years by the best minds in the scientific profession failed to clarify the properties of the hypothetical constituents of the atom, and finally lead to the conclusions that these entities have no definite properties and do not even exist objectively, mere common sense certainly calls for a thorough examination of the obvious possibility that they do not exist at all. But this natural and logical explanation of the difficulties that have been experienced has been completely ignored, while the theorists have gone on an uncontrolled excursion into a weird land of fantasy completely divorced from physical reality. In this instance, the great prestige of physical science, and physics in particular, has operated to its detriment by permitting it to transcend the limits of logic and common sense, unchecked by those restraints which are applied to all less glorified branches of knowledge. As James R. Newman very aptly remarks, quote, "In this century, the professional philosophers have let the physicists get away with murder. It is a safe bet that no other group of scientists could have passed off and gained acceptance for such an extraordinary principle of complementarily not, nor succeeded in elevating indeterminacy to a universal law." Since a principle of impotence is inherently incapable of proof, it is obvious that claims of proof of such propositions are fallacious. Ordinarily, the fallacy is not difficult to locate. For example, the first postulate of relativity, the denial of the existence of absolute motion, is a principle of impotence. It is commonly presented in the guise of positive knowledge, not because it is contended that this postulate itself has been proved, but because the relativity theory is claimed to have been proved, and this is part of that theory. The fallacy lies in the fact that the relativity theory has not been and cannot be proved as a whole, since it includes 4 independent postulates. 2 of these, the constant velocity of light and the equivalence of gravitational and inertial mass, are supported by sufficient factual evidence to justify the contention that they have been proved. Actually, these are not theories at all. They are experimental facts which most physicists were willing to concede even before they were incorporated into relativity theory. But there is no logical justification for extending the evidence in favor of these 2 postulates to the first postulate, which has no necessary connection with the other 2, beyond the fact that it was wrapped up in the same package by the originator of that theory. The first postulate is simply one of the possible ways of getting around the contradiction introduced by the experimental discovery of the constant velocity of light. And it has won general acceptance by default because no one has seen fit to develop a case in favor of any of the various alternatives. Within the framework of accepted theories of space, time, and motion, the constant velocity of light is definitely incompatible with the concept of absolute velocity, and Einstein chose to sacrifice absolute velocity. It is equally feasible to retain absolute velocity and to modify present space-time concepts instead, particularly since there are no great demands on this postulate. The only purpose that it serves is to evade the contradiction that would otherwise exist. It is rather surprising that this possibility has not been explained, considering the tremendous amount of time and effort that has been devoted to research in theoretical physics. There is no obvious advantage in such a substitution of postulates, since it would not change any of the essential aspects of relativity, but the mere fact that there is no definite purpose in plain sight does not ordinarily deter basic research. Exploration of the various alternatives would at least clarify the status of the so-called paradoxes, as these are consequences of the first postulate, and replacement of this postulate by one of the alternatives would either eliminate the paradoxes or substitute a new set for the ones now existing. Okay, we're going to stop there and proceed further with this paper tomorrow. Before I get angry at all the sleight of hands and outright frauds that the physicists have been involved in over the years, under the guise of science, that they've, one philosopher said that they've been getting away with murder, and I believe that to be true. And if you look at the history of these clowns, a lot of them have, passed. They've been imported into this country and into other Western countries from places that are not reputable. We'll just say that, and they're trying to get billions of dollars for their projects, and are, delivering nothing. Okay, and Larson was paid zero for his project, and he's delivering the goods. So that's why we're paying attention to this. Okay, well, we will be back tomorrow to read the next installment of this article. I don't know how much longer it goes on, but Larson does a good job of slicing and dicing here, and just basically showing that how much we really know is not really very much. Possibly get done tomorrow, definitely in 2 days. Okay, have a good day, and thanks for tuning in.